All right. Wow, that's loud. Okay. So thank you for coming to Multi-Cloud GitOps with Red Hat OpenShift. So my name is Cong, and I'm a cloud engineer in the Client Engineering team in IBM. So I'm a core maintainer in the One Touch Provisioning project, and which we will be talking about shortly. So I've been with IBM for about 6 years, doing a myriad of roles from development to managing complex projects in the transport, government, and financial services sector. And finally landing back in engineering where I am today, working on cool tech. So as an engineer, I care deeply about the user experience on the platform. And so you might think I'm maybe biased here, but I think that Red Hat OpenShift is the best Kubernetes distribution out there. And so the reason for that is because Red Hat has been able to combine a lot of different technologies into their product under a single unified design language. And even with that being the case, they managed to keep the installation time rather short and succinct and real easy to install compared to the DIY Kubernetes platform out there. So you kind of get what you pay for. So what I'm passionate about at work is all about building communities, connecting people, and building a supportive work culture. On the other side, I like to doing video and audio editing work. I'm kind of learning about visual effects at the moment. So we have a lot of content to talk about today. We're going to go real fast into some technical content. If you don't get anything, feel free to come meet me at the IBM booth later. All right, so a bit more about my organization. So IBM Client Engineering is a global pre-sales organization. So it's an IBM investment to our clients. And we take the customer through a series of workshops to understand their business need. We do a gap analysis, and then we build a proof of concept, technology, or value, summarized as a proof of X, to show how IBM technology can help solve that business need. And IBM technology here can be our IBM Cloud Pak for like data integration, business automation, security, and all that good stuff. It could be the Red Hat OpenShift Plus portfolio. It can also be the AI apps offerings like Maximo and Sterling. And this entire end-to-end process takes about 4 weeks or less. So with the fast-paced requirement of a CE engagement, in September last year, 2 of my fantastic colleagues, Ben Sweeney, which is Ben is right there, and Nick Merritt, and myself were tasked with building out a point of view on how we can deploy IBM Cloud Pak into tens and hundreds of clusters across any infrastructure providers and any cloud vendors, as long as those cloud vendors support those technologies. So the first step was obviously to automate the setup process. And thankfully, this has been done quite a bit already. So with Terraform script, with Ansible, with Shell script, and with Argo CD as well. But when you step back, have a look at the installation process, this is just a small part of the whole picture. So most organizations that we talk to have constraints and drivers for the management and installation of their platform. Top down, the CIO and the CTOs, they need to streamline the operations across different teams. They need to accommodate for different consumption models to feature teams and run teams with their platform. And they also need to control spending, budgeting, and have visibility across all the resources for security. And they need to apply policies and governance for risk and compliance teams. In bottom up, you have your build teams and run teams who favors that self-service cloud consumption models like PaaS and SaaS. They are typically restricted to build on approved infrastructure vendors and providers. And they need to manage configuration drift for their deployed managed applications. And they also, depending on the industry here, they also need to comply with multi-cloud regulations. In cloud, one cloud just go poof. So when we map these business drivers to technologies, a lot of these are solved problems through Red Hat and IBM technologies. And luckily for you and for me, a lot of the fundamental technologies behind the scenes are open source, which means that you can try before you buy. So with the multi-cloud, multi-cluster application and cluster management and policy enforcement, these are solved with Red Hat Advanced Cluster Management. For the cross infrastructure standardization, you got your OpenShift Data Foundation, which is basically just Ceph, Rook, and Nuba behind the scenes. And for your pool-based GitOps operation stuff, you got your Argo CD, which is powered by OpenShift GitOps. So it's all contained in that one portfolio that Red Hat's got to offer. And for if you want to work with VM virtual machines, then we got KubeVirt, and that is being worked on via the OpenShift virtualization project. And so we have all of these technologies, and how do you integrate them together? And that is where the one-touch provisioning project comes in. One-touch provisioning, or OTP for short, is an open source pattern that we put online. It's an opinionated implementation of the GitOps principles. And at its core, it's about a combination of repositories and templates, as well as how the code is organized when you have a look at it. So the way that we integrate these technologies together is through Argo CD. So out of the box, Rackham, or Red Hat Advanced Cluster Management, now going to be called Rackham for short, combines two major Red Hat open source projects. The first one is OpenShift Hive, and also the second one is Open Cluster Management. So OpenShift Hive provides you with a bunch of custom resource definitions to help you do on-demand cluster creation and management, and also to manage, just cluster deployment and management. The Open Cluster Management project, the second one, provides you with CIDs that allows you to do multi-cluster application deployment and management, as well as policies creation and enforcement. So there's a lot of things together. And these CIDs, they work across infrastructure as long as you have OpenShift or Kubernetes deployed. So when you combine these custom resources with OpenShift Data Foundation, what you get is a really standard platform across every single infrastructure providers. So we start with a good base. And by using Argo CD to integrate these apps together, we get to use some of the Argo CD concepts like sync webs and Argo CD projects. So Argo CD sync webs, if you're familiar, allows you to define the order of deployment of your dependencies very declaratively. And for the Argo CD projects, it allows you to group functional applications together. You will see that example in a second. So how we organize the code behind the scenes is that we use a combination of the app of apps pattern and customize. And if you go to the Red Hat booth right over there, Paul Foster is showing you how to use app of apps pattern with Helm. I think it's a really cool example. So yeah, go check it out. So as a cloud engineer, I would deploy a Bootstrap YAML on the left-hand side. And by using Customize, I can choose to deploy from 1 to 5 applications, depending on whether I want to comment out that line, say I don't want to deploy that, or I uncomment that line, say I want to deploy that application. And these applications are grouped by the functional roles. So the infra project, like namespaces, projects, RBACs, all that kind of stuff, storage is defined in the infra layer. The services contains cross-cutting services like single sign-on, Argo CD, Ansible automation, whatever, that inside services, and then you can deploy your clusters, your few further applications like your, like CI/CD tooling, and then you apply your policies. So looking at the very first example, the infra.yaml file. In this file, there are two custom resources that are created. One is called the app project. The app project is an Argo CD concept that tells Argo CD what namespaces and which resources are allowed to be created in this particular app project. So it gives you that level of control. And the second one is the application itself, where you can define a sync web, a design state in a Git, and also the destination, which is this local cluster. For us, we use sync webs with numbering from 100 for the infra, 200 for services, 300 for cluster, and these are just arbitrary values. Doesn't really do anything, except it allows us to define the order of deployment, and that is significantly big enough, so we can just say 101, 102, 103 if we need to later on the line. And further on, this is like an infra example, so going down the chain, we still use Customize to define what kind of resources we want to deploy and so on and so forth. So by splitting up the code base into layers, we could give the maintenance of the source repositories to the teams who are the subject matter of the topic. And sometimes this is called the Kubernetes ownership model. And this is what we chose to use from our learning with our clients' engagements. So in this example, cloud engineers and cloud engineers like myself would create Argo CD applications with the project that pull in the sources from the repository created by the infra team or the platform team, the risk team. So there's that separation there. And operationally, we also want to ensure that these applications are inner sourced, so the teams can review them and innovate upon them when we work together with the different teams. So before I jump into this demo, which is an interesting demo where we have cluster on AWS and Azure, working together to deploy, use a policy to deploy like Argo CD across all the cluster at build time. I'm just gonna go through and explore some random concept with you so you can have an idea of what's going on. So the first random concept is called a cluster pool. A cluster pool is a pool of clusters. So let's say in this example, I have size of 5. That just means that Rackham will go out to a cloud vendor and says, please give me 5 clusters, thank you very much. And those cloud vendor will create those 5 clusters for you. It's just gonna sit there. And this cluster pool is typically created by the infra team or the platform teams who controls the budget, the sizing, and the visibility from the CIO office. And then as a engineer, I can go and say, I would like a cluster, please. And I create a cluster claim. A cluster claim takes a cluster from the cluster pool, and then this, after a while, become a managed cluster. The reason why it's called managed cluster is because it's being managed by Rackham. And I can go on and so forth, claiming new clusters, or I can also just straight up deploy a cluster using a cluster deployment YAML. So there are benefits and a different reason why you want to do this. So cluster pool, for example, at the moment only support AWS, Azure, and GCP. But with cluster deployment, you can do other historic platforms like vSphere as well. So when we first developed the pattern, the OTP pattern, cluster deployment was the only method available. And this proved to be a bit of a challenge to both the developers and the infra teams. It had a bit of a learning curve. So the developer, they need to know where to deploy it, how big the size of clusters need to be, and also we kind of need to give them the API keys, the console keys for them to go and create the cluster, which is a big no-no. And so then the cluster pools were introduced, and this fundamentally changed the way that we deploy clusters. This allowed the infra team and the platform team to define exactly what the cluster should look like, where it should go into, and then the application developer or the engineer can just say, I want a cluster, please, create a cluster claim, and away he goes. So this method provide the engineers and the developers with the freedom and the simplified workflow to work however they want to work while still set within the guardrails created by the CIO and CTO team. So you got your clusters, then you can create a managed cluster set. Now, this is just a label inside Kubernetes. It's a logical grouping of different clusters together. And what's cool about this, because it's just a label, is that the cluster can come from different clouds. So when you have the cluster set, you have the cluster up and running, you can then deploy applications onto this cluster using the Open Cluster Management custom resources. And there are some concepts here as well. So you got your channels. The channels define where the application source code comes from, whether it's Helm, Git, or some object storage. You got the placement rule that defines where you want to deploy your applications onto. And then a subscription ties those two concepts together, then encapsulated that with an Open Cluster Management application. So earlier this year, we created a complete customization for a major Australian bank where we host the hub cluster, which contains Rackham and Red Hat single sign-on for that federated single sign-on on an IBM Cloud cluster, on an IBM Cloud environment, using the OTP GitOps, infra services and apps repositories to create that cluster, and then also create the managed clusters. So we deploy, I think, 3 clusters to AWS and 2 clusters to Azure using the cluster deployment CR. And then we install Submariner and L3, like a networking layer between all of these clusters, put on it like HashiCorp Vault and Submanager to create a PKI layer, and then install CockroachDB and an example banking app to demo effectively a multi-cluster, multi-cloud, highly available workload. And what this means is that we can demonstrate if we just entirely cut off a cloud, a region, this workload will keep running because it's supported by this layer between everywhere. All right, so now that we have got a lot of the, technicality out of the way, let's show you a demo. And for this, I have prepared a video because clusters take a long time to deploy, usually. Okay, so what I have here is a prepared cluster with a few layers pre-configured. So I have infra, services, and policies. So in the infra layer, in the customization file for the infra layer, I got a list of YAMLs, a list of paths to YAMLs. And so, for example, this thing is called a console notification. This defines this blue bar at the top of the cluster that tells me this is a half cluster for the accelerator toolkit. And then it also defines things like namespaces and RBAC rules, as we mentioned earlier. So this is defined typically by the infra team, where they restrict what exactly can you deploy. And then I'm going to go to the services layer. In the services layer, I've got projects like the external secrets to do secret syncing from external vault or IBM Cloud Secret Manager. We'll see in a second. I've got Red Hat Advanced Cluster Management deployed, and as well as Red Hat Key, which is like a image vulnerability checking tool. Also image registry as well. And now the next one I want to show is the policies. I'm going to skip over and come back to clusters. So in policies, I just have one YAML file, and I just say, pretty please deploy Argo CD or OpenShift GitOps into a set of clusters. So now I'm navigating to Argo CD. And in Argo CD, I have the defined cluster already deployed, and the clusters layer, with that spinny circle at the top, is still running. So go into the clusters, I can see that I have 2 cluster pools deployed, which are these objects here. I got the credentials for AWS and Azure deployed as well, and the 2 cluster claims are being claimed, so those clusters are being created. So let's go ahead and have a look at one of the YAMLs. So inside customization, I can see, I want to go and have a look at the credentials and see what it looks like. So I navigate to that path, Argo CD, infra, just read the path on the right-hand side and go in there. In this file, this is the application that's being deployed. So in the pattern, the application doesn't actually do anything. It just, because we're using app of apps, so it's deployed this application. And in this application, it's going to have a path to another repository that contains the actual source code. And this is happened to be in the OTP clusters GitOps repo, and that is the actual file that's being deployed. And it's an external secret that has a bunch of keys to the actual keys to access the clusters. So basically, you're hosting your keys inside a vault, effectively. And for us, I'm choosing to use the IBM Cloud Secrets Manager. Now, this is just something that I choose to use. For you, you can use HashiCorp Vault. You can choose to use AWS Secret Manager or Azure Key Vault. It can be any kind of vault or secret manager that the external secret project supports. Yeah, so this is just showing you how it looks like behind the scenes. So I created a cluster secret store that references a key and API key to access IBM Cloud, as well as a service URL, which is tied to the endpoint of my secret manager. I'll show you a little taste of what IBM Cloud looks like. So with this particular pattern, you can do 2 things. You can either choose to just specify the actual values inside the YAML, or you can also use Helm charts, which is Argo CD to support that natively. So for the cluster pools, I have these Helm charts, and in the OTP GitOps Bootstrap repo, I then override these values. So for example, on line number 31, I'm specifying the region, the base domain, the public key, and the resource group for Azure as an infra person. And I'm also setting a cluster set label called last mile GitOps. And this will be important when it comes to that policies management later. So this is just, I have a look at a Rackham UI showing you the cluster pools being created, and that we're just waiting for a cluster to be up and running. You can also just click claim cluster right here if you're like a UI person, but that kind of violates the principles of GitOps, so we're not going to do that. For the cluster claims, I'm creating 2 cluster claims. One is Azure and the other is AWS. So in OTP, we aim to cater to that developer experience with the SaaS and PaaS models. So with the PaaS cluster, what it means is, this is a PaaS cluster. Yep. What it means is that the end user of the cluster gets to do whatever they want with the cluster. We don't really care. And that is indicated by a flag called false on line 29. And for a SaaS cluster, what it means is that we, the infra team, controls what can be deployed into this cluster. And the source code will be hosted in our repo. And I say that I enable the managed cluster, And if I navigate to Spoke clusters inside this same repository, I can see the source code for this configuration. And the CI/CD, it's going to fail there because all these like values are not templated. All templated values are not filled in. So it's going to fail later. You see that as well. So now I'm just going to wait for the cluster to be deployed. And it's going to take about an hour or 45 minutes, which you don't have to wait for that at all. So earlier I said that you can define a cluster pool size of 5, and that will let you claim a cluster in about 5 to 10 minutes. But here, because of my restriction for my account, I can't just do 5 clusters at a time. So I'm just using a cluster pool size of 0, and that will create a cluster automatically for you. All right, so after about an hour, both my clusters are created. And that's like a little hot value on Argo CD. Going back to the UI for Rackham, I can go and check out the Azure cluster. I can click on the console URL to see the cluster. Now I've already signed in, so you can't see my kubeadmin secrets password. And this is what the cluster looks like. And now let's go have a look at applications. So earlier, we saw that the AWS cluster is SaaS and has a deployed applications called CI/CD project. And this is reflected in the left-hand side right now, where the application has been created in Rackham via GitOps, but it's going to fail, which is massive X because we knew that it wasn't going to be working in the first place. And with that out of the way, let's have a look at governance policies. So I've defined in that one line earlier is that I want to have one policy to install OpenShift GitOps to all my clusters that have the label last mile GitOps. And according to the screen, the OpenShift GitOps has been installed without any violations. So going back to the Azure cluster, going to operators, it's operators. I can see that I have the operator installed. And when I scroll a bit to the right to have a look at the instances, you can see that one instance is available for me to use, or for the application team to use. So let me check out the AWS cluster as well. I will sign in so you can't see my kubeadmin password. And do the same exercise, operators. I'm going to need to navigate to the right namespace for this. And it's also there. So that concludes our demo. Yeah, so what you saw is an entire infrastructure on 2 different clouds stood up using a single Git repository and 5 other Git repositories because, Apple apps. And so what's next? So what I've shown you earlier, like an example, a customer example, was an Australian bank. But we've also implemented this at an Australian telco, some government agencies, and we are continuously evolving this pattern. And we take learning from both externally and internally within IBM as well, because we would like to eat our own dog food. So the pattern is being leveraged internally across IBM tech sales communities for support, enablement, and demonstrations with large-scale cluster for IBM technologies. And this means that following this year, we might even have the biggest Rackham multi-cloud, multi-cluster, hub cluster, biggest one available in the universe. It's quite exciting to look forward to. So if you want to have that ubiquitous platform across all the infra providers, if you want to reduce the cognitive load on your developers, and if you want to provide that consistent operations across teams, have a go and check out our repository, one-stop provisioning, and have a chat with myself later at the IBM booth. And at the IBM booth, we also have reps from IBM Cloud. We can also talk to you about the IBM Cloud Satellite, which allows you to deploy OpenShift clusters at the edge. All right, and for that, thank you for coming to my talk. We have